What's up everybody, Sean Froon here. So it's been looking like I've been having too much fun making ROTC and Pac-Man in all games, so I decided to really switch the pendulum, or swing the pendulum rather, and get back to some heavy math related engineering stuff for you guys. So I wanted to share just a small but kind of significant problem I solved recently, and that is bilinear interpolation. So let me set up the problem a little bit. There's been a little bit, all this verbiage going around about generative design, evolution solver, whatever you want to call them. I like to call them really cool looping algorithms. So the huge problem is to run through a lot of different routing options and find the best. Here we have Revit running through a lot of different design options, and then we can mimic that with Dynamo, and then maybe run through a whole bunch. But to be able to find the best, we want to get a cost function or rank them somehow, a score, but the terminology is cost function. This could be of the energy, the cost to install it. In case our goal, kind of related to energy, is we want to minimize pressure drop. So in that problem, there's a sub-problem, and that's finding the coefficient for duct fittings to be able to calculate the pressure drop, and that's what we're going to solve today. So there's all these tables that need to have these values looked up in them, and sometimes the angle or the velocity and stuff doesn't fall perfectly in one of the tables. So that's where the linear and bilinear interpolation comes in. So first, let's think about these 45 or 90 degree turntables. So these ones are a little bit easier and only require linear interpolation. So Dynamo works in lists, so we're going to take our table and then represent it in lists. And you can see we have some tricks where we add the input value in front and join it to the list, and then do some indexing to actually get those values, and then plug those values into the linear interpolation formula. So I always like to do gut check, so we'll put in 300 here for the last one and see if we get 0.16 out. There we go. So now let's move on to another fitting. So this is one of the three-way fittings, and it's going to require bilinear interpolation and be quite a bit more complicated. I actually never figured this out in Excel. So the QCs is CFM, and that will be coming from the air, or the diffusers, pardon me, that we already have figured out and placed inside the model. So here's the data table for this fitting. As you can see that we are taking this table and then putting it into list. We're even calling it, notice we have a whole list for the headers and a whole list for the first column. So this kind of shows you where the numbers are coming from within inside the table and kind of how it works, and just a good way to visualize it. So now let's go ahead and maybe change some of these numbers or look at the outputs. So if you kind of look at how this works, you can see that the number is coming from this kind of area right there. If you look at our Q1, Q2, all that, they match up. So now that we have this big long table, here's also kind of how it works. We're then going to find the indexes of what to look up using that same trick from before. Once we have that, we can start to shift around to get the Qs that are necessary for the formula. And then we plug everything into that big formula that we had at the beginning, and then we get it. This part down here is for the other step. Thanks for watching, guys.